Deep breath. Okay. Now, how do I find the 95% range, right? So you probably see this. If you're taking this class halfway through your course because you're desperate, you're probably faced with the question, find the 95% confidence interval. We're going to have to do this forever, okay? So let's find it. Well, if you want to find the 95% confidence interval, let's go to the ruler. And the ruler says that this range is the 95%, range. So 95% of values are there, right? This bar and this bar, right? So standard deviation is 5. So this seems to be like plus 2 bars, minus 2 bars, right? Minus plus 2 z-scores, minus 2 z-scores. So the standard deviation is 5. Well, this is 5. 5 plus 60, which is the average, plus 5, 65. Plus 5 is 70. 60 minus 5 is 55. Minus 5 is 50. So, well, 95% of the people at the Apple store, waited between 50 and 70 minutes. This is how I found it, right? Right? Yeah, this is the statement they were writing, right? I'm like second guessing myself. Is this right? Oh, no. Oh, no, it's not right. Oh my God, what should we do? What can we possibly do? Why is this incorrect? Well, at least it's a closed, well, it is. It is a closed approximation. Let me tell you what's happening. What we did now is that do you ever get OCD? Like, I get OCD quite a lot. What we did just now is that we selected this area between minus 2 z-scores and plus 2 z-scores. I zoomed it in here within the blue square so you can see it, that there's a whole yellow range that we included in our thing that's above 95%, because it says here that the range for 95% values is the range between minus 1.96 z-scores and plus 1.96 z-scores. We use 2. 2 is pretty close of a number, but it's not exactly the number for the gap. So I hope that you can see that here. Like, this is a continuum of z-scores, and 1.96 is not quite 2, obviously. So if you're if you have OCD and your mother's, gonna die because you didn't really account for the precise range, well, this so happens to be what happens to all of the teachers. So they also want you to use the precise estimate. So let's just abide by their OCD. This is the range that we want to select, not this one. Okay, we want to select a range that's slightly more precise, slightly narrower compared to the yellow range that we selected, minus 2 plus 2 bars. Okay, cool. So now we know that this is 50 and 70 minutes, right? The wider range, but the slightly narrower range that we want to select is going to be somewhat higher than 50 and somewhat smaller than 70, but we don't know precisely what the number is. So let's calculate it. Okay, so look, if 50 and 70, they're minus 2 and plus 2, what's the number that's a minus 0.196 and plus 1.86? Let's try to find out. Oh, wait. No, Isaac, no. Where did you get this 1.86 from? Oh, my Jesus Christ, I don't understand anything. I don't have a shot. Yes, you do, man. I got it from the damn ruler, okay? So just keep in mind that the ruler is saying that this point is 1.96. You're like, you see, like this says minus 0.186 plus 1.96. It says 95% right here in the middle. Well, this is where I got it from. You see, 1.96 is right at that point. Yes? No. No, where did you get it from? I don't understand any of this. It's like crazy. I don't get it. Okay, let me explain in a different way. You probably saw Z tables before. Z tables, they're these very scary, big tables with a bunch of numbers that you probably don't know what they mean. Well, let me tell you how to use them. So this is a Z table. Let's use the concept of cumulative percentages, which is something that we used before. Okay. So, because this one says that it's a cumulative Z table, right? So we're going to use that concept. The thing that we're going to do is let's select 50%. Okay, the first 50% of people. So this area of the curve. Okay. that is z-score 0. Can you see that that's z-score 0? Because the average is right in the middle of the distribution. The distribution is symmetric, right? In the visual sense, like both sides are similar. So here we have 0, 0, right? So if you look at z-score 0, 0 plus 0, 0, because you have to add the decimals, right? Like this is 0, 0.00. Well, the 0.00.00 says here that it's 0.50. What does that mean? That means that that is the point for 50% of the people. The cumulative percentage at the 0.00 is 50% of the people. You see what this table does? You find the z-score where you want to stop at the cumulative percentage, and you look at it there, and you just find it. Let me do another example. Let's say that we want to find the goddamn 1.96. So we go down to 1.9 here, as you can see, 1.9. Yeah. And then we go to 1.91, 1.92, 1.93, 1.94, 1.95, 1.96. And that's going to be right here, 1.96. It says here that's 0.975. Okay, 975. Cool. All right. So we do that cut. Cumulatively, this area that we just marked accounts for 97.5% of all people who went to this Apple store. Okay. This is it. That's where I got the number 1.96 from. Okay. So this is how you convert the number 1.96, which is measured in z-scores, right? Measured in z-scores into the percentage, cumulative percentage of 97.5. But you tell me, oh, exactly, but this is not 95%. Well, yeah, because we want to choose the middle 95%, right? And we're going to do that in a second. I just want to make sure that you know where I'm getting the 1.96 from. So if you don't really get it yet, just follow the arrows and everything's going to make sense. Now, we still need to find 95%. So how do we do that? Well, we can use the same thing. So let's find, this is an extension of that table. So this is another part of the table. And we want to find the point at minus 1.96. What's the point at minus 1.96? Minus 1.96. So let's go to minus 1.9, minus 1.91, minus 1.92, 93, 94, 95, 96. It's this one in green, right? This one in green, it says it's 0.025, which means 2.5%. If it's 2.5%, well, then it means that this is the point, a minus 1.96. So I want you to see that we selected 2.5% of the people. Only 2.5% of the people who went to this Apple store took less than 50 something minutes, right? Because it's not exactly 50 minutes. It's 50 something. Okay, but talking about percentages, if we subtract this yellow area from the green area, right? 97.5 minus 2.5, that's 95%. And that's the middle range. That's how I find that the middle range is between plus 1.86 and minus 1.86. So I'm just trying to show you in this different way. Okay? Take a deep breath to process this one. Okay. Now, let's talk about the Z range table. Thank God we don't have to range like this ourselves. Someone did that for us, and there's a table that gives us the range, and I'm going to show you because these are numbers that already exist. So you don't have to do this manually every time. You just look at the numbers, okay? So the range of z-score 1, meaning the range from minus 1 z-score to plus 1 z-score, accounts for 68.27. Please notice that this is not the cumulative percentage. This is what I'm calling now the central range percentage. Okay, it's different than the cumulative percentage because it's the percentage that the painted area accounts for, yes, but it's the central one. It's not the starting from the beginning. Okay. Okay. So the first one, minus 1 plus 1. Second one, 1.865. The point of 1.65 z-scores is the point that accounts for 90% of the people in our sample. So minus 1.65 plus 165 is 90%. Every time is, yes, every time. Every time you're going to get the same 1.65 is going to be the number that you're going to plug it into your formula, and you're going to find the range. We're going to go through the formula later. Look, here's our 1.96 friend. This is the friend that we're just looking at. Look, 1.96 is the precise point for 95% of the cases. It's beautiful, isn't it? Now, pay attention here. The point of 2 z-scores minus 2 and plus 2 z-scores, which is the OCD gap that we were talking about before. is the point for 95.45% of cases, not exactly 95. So if you're OCD, you have to go with 1.96. But if you're just trying to estimate something quickly, you can just use 2. That's a secret. Don't tell anybody. Okay? But if you want to be precise, you have to use 1.96. 2.58 is also a very popular one, which is the point for 99% of cases, right? 2.58. So minus 2.58 plus 258. And finally, 3. Minus 3 and plus 0.3, you're going to get 99.73. Now, there's way more. There's like the 99.9, then there's the 99.99. But you might ask me, hey, Zaki, what's the number for 100% of participants? And I have to answer you with there's no number for 100% of participants because this line tends to infinity. As you can see, it goes outside of our slide. So there's no number. The number here is infinity because it never ends. It never actually reaches 0. So there's always a chance that you're going to have a number that's infinitely larger or smaller, but the chances get smaller and smaller and smaller and smaller and smaller the further you go. You can see that here at this point, the line is almost like inexistent, but there's still this very small chance that the number might fall there. You know, like maybe this is a person who got their Apple Store like results in like 1 second. They just like replaced the battery because it was a whatever. Now, we can never reach 100%. There's a giant every 1,000 years, right? So in the example of height, there's going to be a very, very tall person every 1,000 years, but if that's every 1,000 years, not every day. But really, only 2 of these z-scores for ranges, for central ranges matter, which is 1.65 and 1.86. So memorize that. 1.86 here accounts for 95%, just a quick recap, and 1.65 accounts for 90%. We're going to talk about these later in our next class about directions. Not next class, but in our class about directions. Okay, cool. So, naturally, if you want to find 5%, you know, if you have 90% in the middle, you have 5% here and 5% there, right? That's going to be very useful for later because we might want to find 95% of the cases starting from the cumulative, right? If you want to find a cumulative 95%, you have to use this number 1.65, you see? Because 1.65 is going to be the number at 95% for cumulative range, not for central range. For central range is 1.96.